Hello, the next lecture we're going to discuss is on page 24 of our lecture notes. It'd be a good idea to get those lecture notes out and follow along. The hexadecimal number system. The hexadecimal number system uses a base 16. Thus it has 16 possible digits, and here they are. If you take a look, 0 through 9, and then to get the remaining 6, you have an A, B, C, D, E, and F. This semester, I do not want you to refer to these symbols as the letter. I want you to refer to an A as an alpha, a B as a Bravo, a C as a Charlie, a D as a Delta, an E as an Echo, and an F as a Fox. That's not to be cool. In industry, professionals don't refer to these individuals as symbols as letters. They refer to them as these names because it's just too easy for confusion if you're trying to discuss data or transmit data verbally to another human being. It's too easy to get mixed up between an 8 and an A, for instance, but it's a lot more distinguishable if you refer to an A as an alpha. It doesn't sound like A. It doesn't sound like an 8, rather. So these are the symbols. These are the 16 symbols here, 0 through 9, and A through F. If you take a look in your textbook on page 38, you'll see a table that shows the hexadecimal numbers, the decimal number equivalent, and the binary. Pretty useful to go between hexadecimal and binary, so you should also recognize the binary equivalent for each of these hexadecimal numbers. For instance, alpha is a 1010 bit format. Bravo is a 1011. Charlie is a 1100, 12 if you will, if you're counting in straight binary. This is 10, this is 11, this is 12. Delta would be a 1101, Echo's a 1110, and Fox is the 1111. Very useful to memorize these as soon as possible. Not very difficult, but you use it a lot. What's the big deal about hexadecimal numbers? Well, here's the reason why they were created. They're created to make your life easier. So anytime you're working with hexadecimal numbers, first thing I want you to say is, wow, I'm glad we're using hexadecimal numbers, and this is the reason. Let's say we have some data, and the data looks like this. And we want to put that data in this memory location. It's a lot easier when you're talking to somebody to refer to these in their hexadecimal equivalent than it is to call out the binary number. For instance, you wouldn't want to tell somebody, go to memory location 1001, 1101, 1010, 1111, and put in a 1011, 0010, 1100, 1010. It would be a lot better to convert these individual nibbles to their hexadecimal equivalent. For instance, this is a Bravo. This is 2. This is a Charlie. This is an Alpha. This number is a 9. This number here is a Delta. If you have it memorized, this is an Alpha, and this is a Fox. So what you would tell the individual is go to memory location 9, Delta, Alpha, Fox, and in that memory location put in the data Baker, 2, Charlie, Alpha. Notice we're showing these as hexadecimal numbers by putting a $sign in front of them. Sometimes you can put a base 16 out here, but when you're using computers, you can't put that subscript in when you're programming, so we don't put the subscript in when we're showing this as a hexadecimal number. We're going to identify this as a hexadecimal number by putting a $sign in front of it. Hexadecimal to binary conversion. If you take a look on page 24, you have the number 42 in base 16. It's shown as a 42 with the $sign. And how do you convert that to decimal? We just break it out in terms of its individual nibble bit patterns. So if you take a look here, I want you to notice the 42 is a 4 and a 2. Notice the alpha 3 can be written this way, and notice how you write this as an alpha 1010 and a 3 0011. And I have two other examples for you to look at there. If you take a look on page 25, I want you to notice that how do you go from binary to hex conversion? Well, all you do is you start at the decimal point and you break it out in terms of 4 bits and you put a vertical line in. So I want you to notice here, let's take a look the way I did it. If we have the number 10101111, we start at the binary point and you go 4 digits and you go 4 digits, and then you recognize the bit patterns. That is an alpha, that is a fox. Alpha fox is the equivalent for that binary number. Hexadecimal to decimal conversion, I always recommend you go through binary. Matter of fact, on these next few conversions, I always go through binary. It's so much easier if you do that. And there's other ways of doing it, but for my class, I just have the students always go through binary. For instance, you want to take the number 3 Charlie, hexadecimal number 3 Charlie, and you want to convert that to decimal. That's some number in decimal. So if you convert that first of all to binary, the 3 Charlie is a 3 Charlie. Then you convert that binary number with the weight positions of a 32, a 16, an 8, and a 4. And you add all those up and you get 60 in base 10. So that's 60 in base 10. Notice that what we did is we went from the hexadecimal to a binary, and we took the binary through techniques we learned before and we went to the decimal. Have other examples I want you to work on page 25. What about decimal to hexadecimal? Again, I would go through binary first. You have the 60, write it as decimal, and then recognize the individual bit patterns. 3 Charlie. Two other examples for you to work through. Counting in hexadecimal, I want you to take a look at page 26. I want you to notice here that I have a couple sequences here. Let's say you have a 0, 1, and you count up to 0, 9, and you go 0 alpha, 0 Baker, 0 Charlie, 0 Delta, 0 Echo, and 0 Fox. What's the next number after 0 Fox? It's a hexadecimal 10. On page 26, you can see at the bottom, what's the next decimal number after a 3 alpha 9? What would be a 3 alpha alpha? What's the next decimal number after next hexadecimal number after a 9 fox fox? It would be an alpha 00. You should know the counting sequences and how they sequence up in hexadecimal. The octal number system is on page 27. It has weight positions based on 8 to the 0, 8 to the 1. That is not used very often anymore. It used to be used in a lot of computers like the PDP-8s and so forth back in the 60s and 70s. But we don't worry about octal numbers. You won't have to do any conversion with octal numbers, but you will have to know the binary number system, and you're going to have to know the hexadecimal number system.